Thanks, Holly. So my name's John Haywood. I'm with Bryan on the Mechanical Engineering Group, and I've been asked to be your MC for this session. Um, my role as MC, I gather, is to welcome Bryan, and then at the end to facilitate the questions which Holly just mentioned may come up. In response to my request to Bryan to give a short biography about himself, he gave me the following. Bryan is an electrical and mechanical engineer with more than 60 years' experience in New Zealand and in many countries overseas. He's worked on a large number of small hydro schemes and has been closely involved in some of the failures. I've known Bryan for a number of years on the mechanical engineering group, and he deserves more than this. I came across this passage by William Hazlitt, the famous English writer, artist, and philosopher, 1778 to 1830. You know more of a road by having travelled it than by all the conjectures and descriptions in the world. And this is undoubtedly true, but we don't always want to experience failures if we can learn from those which have occurred in the past. And Bryan's certainly a person who can guide us on that. So please welcome Bryan. Bryan.
Thank you very much. Well, it's all about engineering disasters and how they happen. And there's a whole range of things that can cause engineering disasters. You can go beyond what current technology can do, which people often did with bridges, and the Swiss cheese situation where a lot of minor mistakes, all one after another, lots of a chain when lots of people made the wrong decision, add up to a major disaster. But in my experience, most often caused by a failure to contemplate the possibility that you might be wrong. A friend of mine, a very, very good engineer, always told his staff, never assume that I am right. And I strongly endorse that. So this is what this presentation is all about, failures that followed on from a refusal to contemplate that you were wrong. And this can be summed up in a word: hubris, an extreme and unreasonable feeling of pride and confidence. I've got it right, I know what I'm doing, go away and don't tell me anything else. Never ignore the possibility that you're wrong. We've all done it, I've done it. So I was thinking about this when I started putting it together, and I thought, well, maybe the biggest engineering mistake of all time is the Enigma machine. The Germans believed it couldn't be cracked. The Enigma machine is a coding machine used by the Germans. It was actually developed in the 1930s. It had a whole lot of wheels and it had millions of possible combinations, and so by no conceivable method could you decode what went into it or what was coming out of it. But the Germans reckoned without this place. Most of you will know it's Bletchley Park, which I happen to have visited. Fascinating place. And there they had they developed a thing called a bomb, which was a mechanical device full of relays and all sorts of things and wires. And if the movie was working, you'd see them all spinning around, and what they're doing is decoding a message, which they do just by trial and error and keeping on going through thousands of combinations till they find one that works, and then they've broken the code. And they also developed another machine, which was the world's first electronic computer, called Colossus. And they reckoned to have shortened the war by several years. Whoops, that's too soon. So basically the problem there was that the Germans were absolutely convinced that it couldn't be broken, and even when they changed their naval codes and for a year the British didn't know where the German submarines were, and suddenly they broke the codes and suddenly the German submarine losses have skyrocketed, they still didn't say, hey, maybe they've broken our code. It just didn't cross their minds, and they paid the price. So then we come on to Ruahihi. This is a Hydra scheme that failed in 1981. It was designed 10 or 15 years earlier by Lloyd Mandino, who I used to work for. And it consisted of a lake, McLaren's Lake, an existing lake. Whoops, let me go to this existing lake here, McLaren's, and then a long canal, long through here, all through volcanic debris, down through here, around here, to an intake structure there, and then penstocks down to the power station at the river, about 80 meters head. So what happened was a new team came on after Lloyd Mandino died and decided that instead of using the concrete line canal that Lloyd had specified, they could get away with an earthline canal. Anyway, the day after it failed, the day after it was opened by the Prime Minister, it failed. Real major disaster. And this is what it looked like a day or so later. There's the intakes. Whoops. There's the intake structure, and it all just collapsed in one go, out through there and out down that way. And that's another picture of the debris. It's just unimaginable mess. But you can see it's pretty dodgy looking country. And the cause was early investigations indicate the nature of materials, but the significance of these was apparently not recognized in the planning, detailed investigation and design stages. They just didn't understand the materials they were dealing with. They ignored the advice that it was very dodgy and very nasty volcanic material, and so it failed. Now hang on. So, as I said, Lloyd Mandino recognized the problem, designed a concrete lined canal, and what happened was that not long before it was commissioned, water started leaking out of the bottom of the escarpment that the canal was built on. So they went and put drain pipes in, and this basically hid the problem from them. They could no longer see where the water was coming from. And basically what happened was that the leaking water was eroding the ground. And so, as our geologist put it to us, it was coming down from the canal like that, and then the ground was eroding. So a big hole went up and up and up and up and up, and it all washed out. And so it was opened on the Saturday, failed on the Sunday, but for extreme good luck, it would have killed people. So the next one was the Feyo scheme. I forgot to mention I was heavily involved in the repair of Ruahihi, which, as it happens, was one of the best engineering projects I've ever been on. Very, very good team doing a very good job. So about the same time I was working on another scheme at Feyo in Rotorua. And the civil engineers were a Hamilton-based company with an office in Rotorua. But the client insisted that Leyland consultants be brought in on the mechanical and electrical side, because it was basically a civil engineering consultancy. But the Hamilton people thought they knew enough to do the job that we were going to do, and were not very happy at all about us being involved, which led to bad news. Anyway, we went down to Hamilton and spoke to them, and we spoke to the senior partner, who said that, we've got to work together, and the most important thing is good communications, and he was right. But it didn't happen. So the scheme was a river intake, a river intake here. I got the now go to the point of it. River intake here, and a long canal through volcanic country again. Volcanic ash deposits down to the top of a quite steep escarpment, and 125 meters down below was the Feyo powerhouse down about there. So our job was to write the specification for the turbines. So I asked for the company to give me the lengths of the waterways, because the length of the waterways is very important in writing a turbine specification if the machine is to operate on an isolated system. So they said, here's the profiles, and here's all the information. We put it in the spec, and we got to the stage of ordering the turbines. Just before I did, I wrote them and said, any changes in the waterways? No answer. So we ordered the machines, and a month or two later I was down in Hamilton and saw a profile of the waterways on the designer's wall. And they'd shifted the intake from here, which I don't know if you can see it clearly, from here, which is where they put it in our drawings, to here, upstream. They did that because the geological conditions down here were very poor. So it was a justified move. So I said, oops, we've got a problem. But it's not too big a problem, because running on an isolated system is not all that important. So I wrote a letter for them to send to the client saying, we've had to move the intake. It means it won't run on an isolated system, but don't worry, it'll probably never be needed. But instead of doing that, instead of admitting that they made a mistake, they shifted the intake from there down to there, back to where it was before. And there it was, sitting on fractured ignimbrite, which is this stuff, laid down in a very high temperature sheet, cools and cracks, a well-known problem. And then there's all sorts of other volcanic deposits, including a pumice layer. This is, by the way, is a picture of the washout itself. So what happened was that the water, they had a leak and came out of halfway down the escarpment. So they shut down the canal, and I got onto the Hamilton office and said, look, I've been working on Ruahihi, anything to do with canal leakage in volcanic country. You've got to take seriously, get expert advice in, independent expert advice. And the reply was, no, we've got it all under control. We know what we're doing. We don't need any involvement from outside. And if we did get it, we probably wouldn't take it. And that was the fatal decision. They didn't take it. So they did a patch-up job in front of the intake and grouted all the area that should have been grouted in the first place, filled the canal, and just on Christmas the canal failed and did a major washout. And that's what it looked like. The canal had failed. Canal had failed back behind where the pointer is, came out here, went down there, wiped out the powerhouse, just about wiped out the switch yard. Absolute disaster. Anyway, we managed to repair the turbines, the generators, and the civil works, and we found a lot of other things in the civil works that also needed repair. But it's now running. It's been running for the last 40 years. Right now, I would guess it's earning lots and lots of money. So, why did it happen? Civil engineers didn't update the information the electromechanical engineers needed. They failed to confess to a mistake. It was designed on Hamilton and supervised from Rotorua. The Hamilton designers didn't know that they hadn't grouted all the concrete and all the ignimbrite in the first place, and they ignored the lessons that I was able to bring to them from Ruahihi. A lot of hubris. Now we have the Columbia Space Shuttle disaster. This was the second of the two Space Shuttle disasters where tiles were dislodged off the wing. And when it came into land, instead of the heat-resistant tiles taking all the heat, it got through the missing tiles and destroyed the aluminium underneath and destroyed the whole space shuttle. And according to the official report, NASA took great pride in its history and its can-do attitude. We know it all. It saw itself as a perfect place following the success of its Apollo program. We got men to the moon, we can do anything. It has self-confidence about possessing unique knowledge and how safely to launch people into space. Don't take any notice of anyone else, we know it all. They didn't take easily to criticism from outside. They weren't a learning organization, and they suffered from flawed decision-making, self-deception, introversion, and a diminished curiosity about the world outside the perfect place. It just had to go wrong. So I happened to have spoken to an astronaut who visited a conference in New Zealand, and I had a very nice chat to her. And she said, in the first place, the shuttle was the wrong solution. It was supposed to fly like an airliner, take off and land, take off and land, take off and land. To get to that stage, a new airliner will have flown hundreds and hundreds of times and had modifications until it's really proven to be reliable. Only when it's proven to be reliable is it put into commercial service. This thing, its first flight was up into space, had no real settling in period. Every time it landed, a lot of maintenance work had to be done, so they were never able to fly it near as often as they predicted. And the tiles were often damaged by dislodged tank insulation. This big fuel tank that you will have seen, I'm sure, was covered with insulation because it had liquid oxygen and liquid hydrogen in it. And the bits of it used to fall off, big pieces, this size or even bigger. And everybody assumed that it was soft insulation that wouldn't do any harm. Anyway, they saw a big bit fall off on this particular takeoff, and it did hit the wing. And there was an opportunity once they got into space to inspect the tiles, which they didn't take. And so when it came into land, it fell to pieces. The plane fell to pieces. But behind that was a story of a new management that took over after the first shuttle disaster. Commercial management with not much engineering expertise. And it said, we've got to get it flying again, and you've got to have it flying on a certain date, and here's the budget, go away and do it. The engineers said, well, we can't guarantee we do it, we don't know what we're up against, and so on. And they were told, I believe, that either you agree to do it and deliver, or you're out the door. Sadly, they didn't walk. But it was a case of a management that didn't understand the engineers and was not prepared to listen to them. Then we have the 737 MAX disaster. That's not an actual photograph, by the way, but it is what it would have looked like if it'd been there. Basically, the 737 MAX had a problem with its control gear, and two planes had to crash before Boeing took it seriously. So how the history is quite interesting. A major US airline ordered a large number of Airbus A320neo new engine option. Now the 320 was a relatively modern plane, and it was high enough off the ground to fit this big new engine underneath the wing where it was supposed to go. It was more fuel efficient than 737, and it was almost exactly the same plane to fly as the earlier A320. Now Boeing heard about this order, and the management had a fit, and they all charged down to the airline in southern USA and said, we want a share of this order. And the airline said, well, we want a plane that's the same to fly as the one we've got, but with much more efficient engines. Now the 737 was 70 years old, I think, certainly more than 50 years old, made in the days where people climbed steps to get into a plane. So having it low to the ground was an advantage. So they couldn't lift the plane higher. There wasn't enough space under the wings to put the engines where they belonged. So anyway, management promised they could do it, went back to the engineers, and I suspect told them what they'd done, and the engineers probably had a fit. So what they've found was that it couldn't be fitted under the wing where it belonged. And if you look at these three pictures, here you can see the original 737 with its little engine well under the wing and actually extending up behind it. That's what they looked like when they started. And here's the here's the A320 with the new engine option, a big engine, but well under the wing and not way forward. And then you've got the 737 MAX with a big engine way up and forward where it ought to be. So what did they discover? It had some nasty characteristics. Testing revealed that the heavier engines and the forward placement created new and unsafe flight characteristics. Basically, when you opened the throttles, the nose went up. And so there was a risk that the nose would come up and it would stall and crash. So they came up with a software fix to force a solution. So they put a detector in the front of the plane. They devised this maneuvering characteristics augmentation system to solve the problem. Or was it to hide it? To avoid getting involved in recertification and retraining of the pilots, it relied on only one of a pair of sensors to detect an incipient stall. How come one didn't have to be checked when two did? I don't know. Anyway, this thing was kept secret from the pilots. It was buried way back in a manual somewhere. And nobody was really aware that if this single sensor failed, the plane could crash. Engineers within Boeing complained, but they were ignored. There's ample record of that. So here's a front view of the plane, and down here is the angle of attack sensor, just one. Over here is the other angle of attack sensor, which was not connected in. It's unbelievable, it really is. And so this is what happened during one of the accidents. There's one sensor showing the angle of attack, whether the plane's this way or this way. And here's the faulty left sensor, which indicated that you've got a 60-degree angle of attack. You're going along like this. And here's a picture of it all. Plane flying normally, and if the angle of attack sensor failed, if the plane went nose up, the angle of attack sensor would automatically push the nose down to reduce the risk of a stall. That's what happened when it all worked normally. So push it down and so on. But if it got a false reading and the plane's flying normally, here we are, the plane's flying normally, and this thing cuts in with a faulty reason, it pushes the nose down. And there's a plane with the nose down. Nothing's wrong, but except this thing pulls the nose down. And what happens is that for 15 seconds it just pushes the stick forward and forces the nose down. Then, your poor old pilots panic. Then backs off. So the pilots have suddenly got control again, so they pull the nose up and take a sigh of relief. 5 seconds later, it cuts in again, pushes the nose down. And so it goes on until, in the end, the plane crashes. And so here we are with takeoff. That's basically what happened. Whoops. So this is the rate of climb, down, up, down, up, down, up, down, up, down, and then it noses in. So it just goes up, down, and that's the end of it. When they looked at this, they said the crashes were not the result of a single failure, a technical mistake, or a mismanaged event. They were instead the horrific culmination of a series of faulty technical assumptions by Boeing's engineers, a lack of transparency on part of Boeing's management, and grossly insufficient oversight by the FAA. Boeing was a business under intense financial pressure to get the MAX in the air and into maximum production at all costs. The desire to meet these goals had jeopardized the safety of the flying public. Hubris. So, and one more thing. Some people, quite a few people, believe in man-made global warming, and some of them claim that the science is settled. And that, to me, is hubris. Science is never settled. Never assume that you are right or that what you're being told is correct. That's the way engineering works. So I'm happy to take questions on that. What guidance and thoughtful question you have for young engineers? Always consider the possibility that you might be wrong and that your boss might be wrong, and that always look out. My old boss, Lloyd Manno, used to say to me, when discussing things, it stands to reason. There's got to be a better way. And the other thing he used to say to me was, Bryan, I'm sure if you go away and think about it, you'll realize that I am right. And he usually was. But not always.
Great. So,
Holly, keep
yeah,
going.
no problem.
I'm not finding this.
No problem. Were any of the failures mentioned related to ethical issues between engineers?
What's the name?
Just up the top from Seth. Were any of the failures?
Ethical issues, right. No, I don't think so in these cases. You can say there were ethical issues because people weren't obeying their obligation to consider human lives. But that would be pushing it a bit. No, they were just plain ordinary hubris.
Okay, thank you. Next question from Scott Kelly. How much do you think costs impact?
In the case of Ruahihi, they put in an earth-line canal instead of concrete line canal to save money. So you could say it was a factor. But I'm not sure to what extent it was a dominating factor. At Feyo, it just didn't come into it. It was purely engineering issues and people being not aware of what business they were in. The 737 wasn't cost, it was trying to get an order and use a plane that wasn't suited.
Okay, Bryan, can you hear me now? This is from Greg's story. I've managed to get this going. Would you fly in a 737 MAX today, or are there potential issues still there?
It's a plane that's kept in the air by software, not by good design. It's overcoming bad design using software. Nevertheless, I would probably fly in one because I'm pretty confident that they finally got the software right. And all modern fighters rely entirely on software to keep them in the air. They're inherently aerodynamically unstable. So it can be done, and it can be done properly, but I prefer to fly in an Airbus, thank you.
Thank you. So the next one is from David Naus. Hi, Bryan. How would you suggest communication lines are strengthened in the world of emails, stroke phones nowadays?
Sorry. Sorry, I missed that.
He's saying that we live in a world where communications are based on emails and phones.
Yeah.
And how would you suggest we should strengthen those communication lines in the present world?
Yeah, in the present world, we've got sometimes less face-to-face communication we had. When I was working on the repair of Ruahihi, all the engineers got together once a month and discussed everything. So I was there when the geotechnical engineers were talking, and they were listening to me talking about water hammer and things like that. So, and you got to know everybody and have confidence in them. If it's done remotely, you don't get that same feeling, and you don't get that same interchange of information. But it just makes it important to interchange information and not assume that one group doesn't need to know this. In the case of Ruahihi, they assumed that you couldn't have longer penstocks because of water hammer problems, and I was able to say that because of the particular design of the machines, we could go to much longer penstocks, and that was why the scheme was salvaged. Other than that, it would have been abandoned.
Okay, thanks, Bryan. The next question is from Katharina. How do you detect hubris in an organization?
Nobody needs to tell me how to do this. You just go away and do what I've said. Yeah, don't ask questions. Just get on with it. You've run out of money. Stop work on that. It's an attitude of mine, but basically it's refusal to exchange information and chew the fat about possibility that something should be different. I think if you're there, it's fairly obvious. I mean, in my firm, we always had morning tea around the same table, and we used to chat about everything. That's a good protection against hubris.
Okay, Bryan, the next one is from Flash Langley. Engineers rarely in the most senior decision-making roles, let alone external politicians. It doesn't continue that, Flash. Engineers maybe he means that engineers are rarely in the most senior decision-making roles, let alone external politicians.
Yeah, and that is true. And our duty, and a very important duty, is to tell our clients and the public what they need to know, not what we think they want to hear. And that doesn't get done enough. I was in a big firm once, and I said, well, what you're saying isn't quite correct. Yes, but that's what the client wants to hear. How do you know it's what he wants to hear? Somebody may have told you that, or you may have assumed that's what he wanted to hear. Sometimes it's difficult to tell him what he needs to know. Sometimes it takes some skill to get it across, but you've got to do it. Otherwise, disaster will follow, or probably follow.
Thanks. That's good. It's one of those ethical things that Engineering New Zealand requires. The next one is Sean. How might we, as a profession, go about strengthening our analysis for managers? We often get pushback from the uneducated, and it seems many of the failures you've raised had this as a common failure point.
Yeah. Okay. You've got to be good at presenting information and getting the key points across and not lose them in jargon and going into too much detail. You've got to work out what the key points are and make sure they come across. Just one or two single issues. If you do this, there's a chance it will fail in this way. And never mind, there's a whole lot of other issues involved just to get across that there is a potential for danger and to convince them that you know what you're talking about. You've got to speak in language that they understand, not engineers' language.
This is next one from Cam. Is the proposed engineer licensing system a potential solution to these hubris situations?
I doubt it. Engineers licensing is a panic reaction to the CTV building failure. And it says if somebody's got a stamp of approval, then we can trust his designs. It largely ignores what I think is a very major problem, which is peer review. All these designs were supposed to be peer reviewed, and we're not doing it sufficiently thoroughly and sufficiently independently.
Good one. So the next one is from Fergus Rhodes. Could mandatory peer reviews, either contractually or in regulation, help prevent these issues? I think you've just
I pretty well answered that. Yes.
Right.
But there's a limit to the number you can have and how much time the peer reviewers can spend. It's a backup to failure of design, but it doesn't. It's much better if you have a good design in the first place. It doesn't need peer review, but you shouldn't rely on peer review as a substitute for thorough design.
Okay, thank you. So next one from Colin Whitaker. Thanks for an excellent presentation and the message of asking ourselves whether we are wrong. I'm involved in teaching engineering in the university system. Any suggestions regarding how we can start to instill these lessons in our students so that they are more prepared for their careers?
Well, my father used to say to me, believe nothing of what you hear and half of what you see. That's quite a good start. Always be skeptical of anything until you have satisfied yourself that it's credible. Don't believe something just because somebody says it's true. And, in the case of many things, say, well, everybody believes that this is okay, therefore it must be. Doesn't follow.
Thanks, Brian. So the next one's from Sumit Nagargoshi. Would you like to share any interesting memory that you recall from your work experience, which you remember till the present date?
That's going back 60 years. Oh, I can remember occasions when I was so convinced that I was right, I ignored the possibility I was wrong. One small Hydra scheme on the West Coast, I had an idea that a particular design was very good, and potentially was, but the designer designed the draft tubes on the turbines wrongly, and at those days I didn't have enough experience to know that they were wrongly designed. So that little turbine never put out its designed output. I should have picked it up. Other people should have picked it up.
There you go. So a bit of hubris in your background there, Bryan.
Oh yes. We can all make mistakes.
So
I've had more opportunities than most.
The next one's from Mark Sterling. Given the horrid lessons we have learned from some major failures, e.g. the failure of the CTV building in Christchurch, do you think similar mistakes will be made in future? Or have we safely moved on to a higher level of safety and confidence?
Right. My view, the CTV building really went wrong when somebody rang up the designer and said, I'm not very happy with this design, would you get it checked? and the designer says, there's nothing wrong with it, it's perfectly all right, I know it's good, and I'm not going to do any more checking. And that was hubris. Big way. About whether it's going to happen more in the future, we've got too much relies on computers, and people believe what comes out of computers. I had one occasion where I asked someone to investigate a small change, and he put it in the computer and came out with a big output change. And I said, it can't be right. And he said, oh yes, look, I've come out of the computer program, it must be right. No, it can't be. So we checked on how he'd input the data into the computer, and he'd put it in the wrong. So people believe what comes out of computers and don't say, does this add up to common sense? Does it fit with my experience? Or should I go and ask Fred if this is reasonable? Because it doesn't look right to me. And computers don't make mistakes, but if they're given the wrong data, they produce the wrong answer.
Yeah. Thanks, Brian. I believe that too. This is from Arash. MBIE just had a new announcement yesterday about proposed changes in regulating engineers. In the presentation, there were many cases that management made a wrong call despite engineers' advice. Do you have any thoughts how NZ regulation should change to protect engineers against non-technical drivers such as time and financial pressure?
I don't think you can do it regulations. What we should be doing, and what Engineering New Zealand should be doing, is emphasising the importance of good engineering at every possible opportunity. So that, for instance, on the Climate Commission and all that, there was virtually no engineering input into their report. And what they say we should do, the resources to do it just don't exist. So it's a lack of engineering input and a lack of understanding by the decision makers into how important engineering is, how important it is to get good engineering advice early on and listen to it.
Yeah, good. Thanks, Brian. Next one's from Ian MacDonald. Do you think that unrealistic deadlines can often result in shortcuts? I think he means engineering shortcuts.
Yes, of course. You could say it's the 737 story to a large extent. They had to get it out quick. Come on, we can't shake around any longer. Get it out the door. And the same with the space shuttle. Exactly the same with space shuttle. And in some things, particularly many software projects, it'll be finished when it's working. And don't try and rush it because it won't work.
Thank you. So this is from Ian Walsh 2, or number 2. While we have a duty of care when becoming aware of a potential issue, the degree to which any expression of concern to a decision maker is accepted and acted upon is surely a separate professional matter. So what he's saying is, while we have a duty of care in becoming aware, the degree to which any expression of concern to a decision maker, that's presumably the boss, is accepted and acted upon is surely a separate professional matter. Tricky one to answer that.
I'm not quite sure what he's trying to get at, I'm afraid. So I think I'll have to miss that.
We'll pass on that one. Sorry about that, Ian Walsh 2. We'll go on to Jack Roberts. How do you best deal with situations around organisational hubris if you think some hubris is occurring?
Talk to lots of people quietly. Try and maybe get in touch with somebody who knows somebody further up the organisation who can pass on a wise word. Softly, catchy monkey is very much a good idea. Try a variety of routes. If you charge in and bash your head and make a big fuss, you'll get knocked on the head and then everybody will gang up against you. So it's just a matter of working a whole lot of different options.
Righto. So Daryl this is the next question from Daryl. Have you ever heard of a case where workers have refused to build a design, stating the design will fail from an engineering point of view, and walked away from the project?
I don't think I have, but I can imagine that it exists, certainly, in some countries. But I'm sure there will be cases where, particularly on safety things, workers have walked off and said, I'm not going there."
It's an eternal problem. Yeah. So the next one's from Seth Groombridge. Were there any limitations in the maintenance phase of the canal project in regards to iwi protocol with land rights?
No, this is long before all that stuff raised its ugly head. Or raised its head was probably what I should have said.
We'll just keep that to a note, shall we?
Yeah.
Okay, the next one's from Scott Kelly. Given the demand on engineers in New Zealand at the moment, there are a lot of overseas engineers moving to NZ. With the overseas engineers comes various ways of doing things that aren't necessarily consistent with how things are done in NZ. Although builders keep building things the Kiwi way, not necessarily following the drawings. Do you think this issue is more significant than engineers having hubris?
I think it's significant, but it could be part of hubris, because one of the things for civil engineering is civil engineers from overseas don't understand the horrible geology that we've got, the volcanic materials and all those sort of things. I mean, if you live in Norway, you're just dealing with one monstrous piece of rock. In New Zealand, you go 10 feet, and there's a dramatic difference in the materials. And you could say that that's hubris, saying, well, it worked in Norway, why won't it work here? Because you're building on a pile of rubbish.
So there's one here from Sean. Would you support a more blind peer review? So that's a blind peer review system. It's often the designer who puts forward who they want to check the design, which is an obvious conflict.
It's a major problem.
Or a potential conflict.
Yeah, it's a major problem.
Would a roster of peer reviewers selected at random provide a more independent process?
It's certainly something that should be thought about. It is a major problem of PAL review rather than peer review.
Okay, good one. The next one's from Katharina. We had Katharina before, I think. How do you maintain skepticism in a fast-paced environment where decisions are required quickly and management require response times that don't allow time to reassure oneself that information is sufficient to be correct?
As best you can is the only answer, and it's not a good one. But underlying all this into all of us is engineering judgment. In a lot of cases, you don't like things because it just, your basic instincts say, there's something wrong with this. But in those cases, that's the signal that you need to do more investigations. Going to somebody and saying, I've got a gut feeling that this is no bloody good, often won't get a very good response.
Yep. So from Angelina Tan, what do you recommend to young engineers who will continue on their career relying on softwares when older generations who can verify the validity of software results retire?
A lot of site experience is probably worthwhile, because the computer programs don't fail. It's the input data is crook, and if you've got a better understanding of what the inputs might be and how on site what's been designed may not work and may have to be modified or is just unrealistic, it's better. And it's not an easy question to answer.
No. So from a person with the initials MJH, some great questions.
You're being nice to us.
Question. It's an expression of thanks, Bryan. At last you got some recognition here. Some good questions. Really enjoyed the discussion on the issues raised. Thanks. Thank you, MGH.
Of course.
I don't see any more questions, Bryan, so perhaps we're coming to the end of the process now. Do you think that that's about the end, Holly?
Sounds
Well,
great. Yes.
I'd like to thank everybody that came and listened, and particularly for the very good questions we've got. It's only when you get a load of good questions you realise whether or not you've had any effect.
Yes. Yes, I think they were very good, and thank everybody too. Okay, well, that's it from me. And thanks, Bryan. That was very, very
Thank
good.
you, John, for
Much
handling
enjoyed
it
it.
so well.
Thanks, everyone.
Pleasure.
Okay.
Thanks, Holly.
Bye.
Bye.
Bye.